So today what we're going to do is continue to work on how to do math with scientific notation, but our focus today is going to be on division. So that's our objective, is to understand you know what, I marked it off so you can hold on to it. Understand and apply the process for dividing numbers in scientific notation. Okay, so understand and apply the process for dividing numbers in scientific notation. All right, so here's a scenario. This is going to come out of example 2, out of the lesson 2.4, and this is on page 54. So when you go home and you look online, you can see this. And what they do is they said that the sun makes an orbit around the center of the Milky Way, that it travels a total of 2.025 times 10 to the 14th kilometers. So the orbit of the sun is 2.025 times 10 to the 14th kilometers. And it says the orbit takes, so time of orbit, this is why we don't want to be suns and stars and planets, it takes 225 million years to do that. It's a long time just to go in a circle, right? That's a long time. Okay? So the question wants to know what's the rate. And rate is a fancy way of saying speed. So that's what we're going to try to solve for. Okay? And if you remember, you might have learned a formula called the dirty formula, Mr. Canody calls it. And it's D equals RT. And that's distance equals rate times time. You're going to use it in your science class a lot, and it'll crop up in a lot of problems that we do. So distance equals rate times time. So the question is, what's rate? So if I wanted to take this equation and get the r by itself, I'm going to solve it like I would any other equation. I'm going to do opposite operations. What math is going on with the r in this problem? Over here, the d equals rt. What math is going on when I have two variables sitting next to each other? Mark? Multiplication. So the inverse of multiplying would be dividing. So if I divided both sides by t, and then I'm going to use what's called a symmetric property, the result of dividing by t gets me r by itself, and I get d over t. Okay? All right, so that's what I'm going to end up doing, is taking that distance and dividing it by time. I notice there's a problem with the time. And the problem with the time is that it's not written in scientific notation, and I need to make sure that it's written in scientific notation. So how are we going to do that? How do I interpret 225 million in scientific notation? Well, how many zeros do you have when you're in the millions column? 6. So that's the first thing we're going to do, is we're going to take this guy and make him 225 times 10 to the 6th. All right, is that answer in scientific notation? Do I have a number between 1 and 10? No, I'm well above that. So I'm going to have to rewrite this. Okay? Aaron, is that you trying to help me with this answer? Okay, and what do you think the answer is going to be? It wouldn't be to the 6th power because that's right. I had to move the decimal point twice in a large number So I'm going to have to add that to my exponent. Remember, large numbers get positive exponents. So then that would give me 2.25 times 10 to the 8th. So now I have this number, and I had this number, by the way, this is in years. So what I'm going to do is on the next screen, I'm going to do the division with those two numbers. Okay? So, everybody ready for me to move? Yep. Yep. Bueno. Okay. So to figure out the rate, I need to take distance and divide it by time. So for us, the distance was 2.025 times 10 to the 14th kilometers. 14 could be a little better. And then we're going to divide it by time, which we just came up with was 2.25 times 10 to the 8th years. So my rate label will be kilometers per year. Okay? So, let's think back. Quotient rule we had on our review notes on Friday. What do we do when we divide monomials and the bases are the same? What do we do with the exponents? We end up subtracting them. It's got to be opposite to what we did yesterday. Okay, so we subtract. What are we going to do with the coefficient parts, though? We're going to end up just doing division because that's what it tells us to do. So this problem breaks into three major parts. We wrote it down yesterday. We're going to take the coefficients, or in this case, the decimal values, and we're going to do division with them. So first, we're going to divide the decimal values. The next step is really just more of a placement thing. We're going to write times 10. Because we're multiplying by the power of 10. And because this is a division problem, we're going to end up subtracting the exponents. So that would be my third step. Subtract the exponents on the power of 10. Okay? So here comes the fun bit. We've got to do long division with decimals. And we have to follow some rules. So rule number one with dividing with decimals is we can't. So what we have to do is make sure that the divisor, I move the decimal point over until there's no more decimal point. It took me 2 places to move it. So now I'm going to move it 2 places in my dividend and bring it up from its new home. Okay? So now I'm really dividing 225 into 202.5. Okay? So now I got to figure out where I can start my division. So 225 can't go into 202, but it can go into 2025. So let's see, how many times would that be? Let's see, if we did 4 times of 225, I think that's going to give us 900. Is that right? Yeah. So then we could do that 2 times to get to 1800, 3 times, if we did that, so another 8, so let's try 9. Let's see what 9 looks like. So we have 45, we get 18 and 4 is 22, we get 8, oh, look at that, 18 and 2 is exactly what we need. So it went in 0.9 times, okay? So what we have right now is 0.9 times 10, and then what's 14 take away 8? 6. Now, we run into a problem that my decimal portion doesn't meet the criteria, right? It's less than 1. So we're going to make adjustments if necessary. And the adjustments we make have to do with the decimal value. Is that decimal value less than 1 or greater than 10? Okay, so we're going to make our adjustment. We're going to have to move the decimal point 1 place. Because I had to move the decimal point 1 place and it was a very small number, what exponent am I going to put on that 1? Is it a positive 1 or a negative 1? It's going to be a negative 1 because remember we associate negative exponents with originally small numbers. So we move that, and that gives us the answer of 9 times 10 to the 6 plus negative 1 is 5, and then we give our final label, which was kilometers per hour. Or, sorry, you're right, year. An hour, it's like, whoa, that's pretty fast. Wow, that's pretty crazy. All right, now here's the problem with this one. It actually worked out neatly. My divisor went evenly into my dividend. That's not going to happen. So have your worksheet out, and we're going to do number 1 together off your worksheet. So you're going to want to do this on your homework page, probably, because this is going to be your homework problem. So we're going to take this problem, the 7.8 times 10 to the 4th divided by 8 times 10 to the 1st. So what's kind of nice about division is that setting up the problem to divide, the decimals are already put into place. It's not like with multiplication, I have to go back and count how many digits came after decimals. Jacob?
Do you have an extra worksheet?
Probably in the bin over there where I put all the extra worksheets. So we break our problem into 2 major components. We're going to have 7.8 divided by 8, and we're going to multiply it by 10, and then the exponents we're going to numerator take away denominator, so 4 take away 1. And off to the side, I'm going to take 7.8, and I'm going to divide it by 8. So what I have is, bring up the decimal point. I had no decimals in my divisor, so this is a relatively easy problem. 8 can't go into 7, but it can go into 78 9 times. That's 72, and I get a difference of 6. Bring down the next digit. 8 goes into 60, that would be 7 times, which is 56, and has a difference of 4. Bring down the next digit. And 8 goes into 40, 5 times evenly. So we're kind of lucky that this one terminates as well. So we get 0.975 times 10, and 4 take away 1 is 3. Is this answer good, or do we need to make adjustments? Yeah, we're going to have to make adjustments. The adjustment is made so that I get 1 digit in front of the decimal point. So I moved the decimal point 1 spot. I'm going to add that to my exponents. Now my question is it a positive 1 or a negative 1? It's a negative 1, and the reason why it's a negative 1 is because I had a very small number, and small numbers have negative exponents. So my final answer is 9.75 times 10 squared. And that's it. Done. Okay? That was a nice one. Let's do an ugly one. Let's do number 2 together. Okay? So right now, I'm whittling your homework down. Okay? So we don't have as many problems to do. So we're going to do one more. Everybody good with this one? Mm-hmm. Okay. If Ryan says he's good, then I guess we're good, right? Everybody got it? Jonah, you got it all?
Yep.
Okay. Bailey, you good? Connor, you got it? Okay. Jacob, you got it? Kelly, you good? Are you already working on the next one, Kelly? Okay. I thought so. All right, here we go. Ready? So the next one is ugly. 5.3 times 10 to the 3rd, or 10 cubed, divided by 7.65 times 10 to the 5th. So the problem breaks down into two parts. 5.3 divided by 7.65 times 10, and then I do numerator, take away, denominator. Always that order. So it's 3, take away 5. Here comes the not fun part. I have to do long division. I'm going to take 5.3 and divide it by what's on the bottom, the 7.65. Now here we finally see that issue we had in the first example where I cannot divide by a decimal, so I do need to move the decimal point over till it ends at the back of the number. I moved it 2 spots, so I'm going to do the same thing to the value that's under the division symbol, and I'm going to fill up any blank with a 0. And then I'm going to bring that decimal point straight up from its new place into the answer. Now I'm ready to divide, and I'm really saying 765 dividing into 530. Okay, well, 765 can't go into 530, so I'm going to put in a 0. So now I'm really doing 765 into 5,300. So if you guys remember from elementary school in 6th grade when you're doing with division, you kind of just look at the first digit and the first 2 digits. So how many times can 7 go into 53? And that's kind of where we start our estimating process. And that would be what, Taylor? 7. So let's try that. So we're going to do off to the side. I'll do it over here. 765 times 7. So I get 35. 42 and 3 is 45. 49 and 3 is, oh, dang nabbit. I get 53, 55, and I need 5300. So it was just too much. So that just says adjust your guess down, and we're going to go with 6. Now notice I'm not going to erase my work, because who knows if I need that 7 another time. So I just leave it there. And I have, let's see, 30, 36 and 3 is 39, 42 and 3 is 45. So I have 4, 5, 9, 0. So I do subtraction, 0, take away 0, 0. Here I can't divide, so this is when I rename. 10 take away 9 is 1. I can't do 2 take away 5, so I rename. 12 take away 5 is 7. As long as that difference is smaller than the divisor, I'm still good to go. Okay, so now I need to see how many times does 765 go into 7100. Well, 7 goes into 71 at most 9 times. I can't make it go into 10 times because I can only do 1 digit. So we're going to try 9. So we have 765 times 9. So that gives me 45. We have 54 and 4 is 58. 63 and 5 is 68. And then we subtract. So 10 take away 5 is 5. 9 take away 8 is 1. Oop, I have to rename again. 10 take away 8 is 2. So that was a 9. Okay. In order to get an answer rounded to the hundredths, I need to have a number to the thousandths. So I am going to have to go a little further on this one. So bring down another 0. 7 goes into 21. 3 would be exact, but I'm actually not at 7. I'm in 765, so I'm going to have to go with 2. So then I do that. 10, 12, 13, 14, 15. I get 1, 5, 3, 0. So I subtract. I get a 0, I get a 2, I get a 6. So that was 2 times that went in. Okay. So at this point, I'm going to stop my division. My remainder is less than what I divided by, so I'm good. Jacob.
When I subtracted like 5,300 and 4,000 minus 4,590, I get 800.
I think you didn't take 1 away from the 3 to take over to the 0 to make a 10, leaving you at a 2, and then when you renamed and made it 12, 12 take away 5 is 7. So a lot of times what happens is when people rename, they don't cross off, and so then they forget what they've done.
Which would be 870?
So it would be 700 right here. Should be 710. So at this point, we've got 0.692 times 10 to the negative second. Do we need to make an adjustment?
Yeah.
Oh, yes, we do. So we're going to have to move the decimal point one spot. And what sign are we going to put on that 1 in the exponent?
Negative.
I had a very small number because the first thing I saw was a decimal, so it would be a negative. So the answer is going to be 6.92 times 10. Negative 2 and negative 1 is negative 3. Okay? So that's what you're going to be doing on your homework tonight.